So why don't we start with and look at emotional AI, right? And I know Atul, you've been working with Amazon, right? And you a lot of it on your marketplace. So what are the challenges? What you're actually seeing, right, in terms of emotional AI, and how do you define those?
Okay, I was actually sort of before I got onto the stage, I was wondering why this was the last seat to be occupied. Now I know. The first question would arrive for me. Okay, so as far as sort of Amazon is concerned, and the biggest sort of uh, avenue that we are seeing for emotional AI is on the retail side, and sort of we were talking earlier about the fashion industry, and we are trying to sort of influence the fashion industry into a state where we should be able to recommend clothes to people based on their emotional state. So we are not there yet, but that's what our final goal is. Right now, we are more handling with problems related to what clothes or what clothes recommendations go with what accessory recommendations go with what. But a large portion of that going forward we see is going to be based on emotional AI, where we would like to find out how are you feeling today, and correspondingly then recommend to you what clothes you should select to wear on a particular day. How does that make you look, and so on and so forth. Similarly, sort of there are other areas on what would you like to buy today. That sort of is again something that we think that is going to depend a lot upon the emotional AI.
Sure, I think that's a pretty interesting one. Like, for example, if I want to go for a party, then if I want to ask Amazon what kind of does it, if I say I want to buy party wear, then it should sort of show me
Exactly.
all those different apparels which
Right.
actually I can pick up from.
Yes, and sort of exactly. And if there is a particular shirt that you like, we would like to recommend to you a watch that goes with it. Sort of all the other accessories and the other shoes that go with it, and so on and so forth.
Sure,
Yeah.
sounds good. So, Ganeshan, back to you. I mean, so you're working with Phillips, and you deal a lot with medical side with the world, right? And a lot of human emotions are involved, especially when we talk about medical science, right? So, what are the key challenges what you're facing when you talk about emotional AI and some of the scenarios what you're actually seeing in the medical side?
Yeah. One of the challenges, whether it is emotional or AI, is that acceptability of technology or acceptance of technology. For example, ECG auto analysis has been there for at least 10-15 years. So once you take an ECG, you get a small write up on the bottom of the ECG page saying that there is a possibility of this particular disease. Most often the cardiologist will throw it out and then he'll do his own analysis. So the acceptance part of whether it is validated, what exactly has gone into that, even a 99.999% accuracy may not be enough. Okay, so when you're designing an emotional aspect of it, we have to understand, we are dealing with multiple users. For example, when we design a system, it could be the user, could be the doctor, it could be the patient, it could be the patient's mother. Okay, so and each person has their own emotions of different level of trusting the technology. So we have to take that into that particular account. For example, the simple example outside of healthcare I can think of is the Microsoft Clip It. That small icon that would pop up in Microsoft Office, saying how are you feeling today, or do you want help with your Word one. And Microsoft removed it because most of the people thought of it as an annoyance. Okay, simpler thing for example, whenever in an ICU, if you take a look at a serious situation in an ICU, whenever the the heart rate goes up or the oxygen level goes down, there is an alarm from patient monitor. Most often the nurses turn it off. Okay, because it's an annoyance for them. Okay, so these are the challenges we have to deal with, that okay, fine, when to give an alarm. And there is an alarm fatigue in ICU is a well recorded phenomenon. So that as a medical treatment, you are supposed to raise an alarm when something is going wrong with the patient. But if the nurse is taking it in a different emotion than what it is she is supposed to take it with, then we need to understand the emotion of the nurse and then act accordingly. So whether whether the right kind of nurse should be involved in treating that patient, or whether it should be escalated to the doctor, or whether something could be automatically managed, all those things come into picture. This
Sure, I think there's some pretty interesting scenarios which we see every day in a real-time world. And Sachin, I mean, your app, right, Niki, I think it has the ability where you can actually talk to it and it can tell you and recommend you, like for example, if I want to know what's the cheapest ticket to go up, right? And I mean, then it can sort of recommend, right? So what are the scenarios we are actually seeing, and how does emotional AI play into your app when you're actually working on it?
Sure. So, given ours is a more conversational interface, generally people are a little more expressive, and if they are sort of annoyed, they always invariably tell us that they are, and they are typically very verbose and elaborate. So it's easier for us to sort of understand emotions compared to, I won't say the easiest, but compared to web interfaces or app interfaces which are more tab based. Getting a feedback from a user is more natural, and therefore the problem is also more intense to sort of really understand a user's emotion, because there's a lot of business opportunity that sort of lies underneath. For example, if a user is depressed, it's easier for us to recommend an ice cream, right? Because it'll help them cure that. If a user is sort of really happy, he would prefer to spend more. So depending on the use case, uh, I mean, it's sort of important to invariably take emotion into account whenever trying to, you know, whenever trying to deal with a particular customer, and there is definitely a big opportunity as well for businesses. However, it's a little difficult as well to sort of understand. We do a lot of mining of user conversations and trying to understand emotion that lies underneath. But the complexity sort of keeps on increasing, with more and more usage. Uh, uh, for example, trying to understand sarcasm is very difficult. You so let's say you ask Nikki that show me the cheapest cab available, and Nikki figures out, searches across Ola and Uber, and figures out that only Uber uh, luxury is available. Right now, go and recommend that to a user, and he'll say, "Yeah, right." Now that's a sell which is hard to make, and from a user from Nikki's perspective, it's also a little difficult to really understand whether a particular user is looking at is looking at purchasing that item. But and therefore we have checks and balances in place. More often than not, we always ask users to concur a particular result. So yeah, and until unless he confirms that this is the product that he wants to buy, we don't really recommend him. But yeah, it's a little difficult problem, but it's a very big opportunity for businesses as well.
Okay, sounds good. And Tapati, I mean, you work with various domains across, right? And so, what are the key challenges you are actually seeing when it comes to emotional AI in different verticals and segments?
Sure. So, part of Wipro Homes 3.0, we have something called brain machine interface, right? So, when we look at emotion processing, there are multiple aspects which many of our friends have covered already. So, we have spoken about the internal biochemical reactions or electrochemical reactions of the brain, which is usually figured out by the fMRI or DTI kind of stuff, which are MRIs. And then there are gestures, there are facial expressions, and there are languages. That those are multiple channels of expressing emotions. And when you talk about emotional AI or a brain machine interface, the first thing it should be able to do is it should be able to capture and integrate all those emotional expressions from all those multiple channels, right? Starting from touch to how you look to how you speak to how you say things. So all those things will have to come together. So that is actually a very big problem to start off with. The second problem that we see is in terms of our extreme lack of understanding in the first place in terms of how human brain processes emotions, right? So first we should understand how we process emotion so that we make the artificial version of it, right? So our understanding of emotion itself is, probably just about 5% we have achieved so far. But we have certain interesting use cases actually, in our pipelines, and we work very closely with some of our partners. So there are small startups, mostly they sprung up from MIT. MIT Media Lab, Pickard, actually, she is the stalwart in affective compute. Affective computing is what we talk about when we talk about emotion processing, right? So Pickard actually floated two startups, Affectiva and Empatica. So they have Q sensors and Galvan activators that actually can process your emotions, can track your emotions based on the blood flow and skin temperature changes. So we are trying to build some stuff which are essentially stress regulators in your workplace. So you talk about digital one office kind of situations where front office, back office come together. Think of a call center employee, right? I mean, the kind of abuses those people will have to go through on a daily basis. There are actually some, neural network algorithms available that can actually run support vector machines that can differentiate your appetite to take stress. That how much or how less agitated you become if somebody is abusing you, either through, as a call center employee. So those are certain use cases which are straight away impacting the occupational hazards of people. 45%, if you ask me, amongst people like you and me, people like us, have some kind of mental uh, issues, right? So how about insurance? If you look at insurance, most of us are under health insurance, and all those use cases are typically to do with our physiological illnesses, right? You won't find a health insurance which covers us for depression, for melancholia, for bipolar disorder kind of stuff. And if you ask, I mean, all of us, we know that it's first of all very hard to detect, and secondly even harder to actually get back to a normal work life once we are hit by such, I mean, we are unfortunate enough to be in that 50% bracket, 45% bracket, to get back. In fact, Deepika Padukone actually was very vocal on the social platforms about that. So those are certain use cases where we talk about occupational hazards, stress levels, how emotional AI can actually be used to monitor them and essentially to prevent. There are in fact solutions available. We were talking about a solution called Velinor that can actually track all those biosensical parameters and can predict whether a person is uh, thinking of something related to self-harm. So all those things that we saw in Minority Report kind of movies are technically possible. So the art of the possible is infinite, but it's all limited by our extreme lack of understanding about how human brain processes emotions. As our friends were mentioning that anger, for example, is a very easy to codify emotion, whereas sadness is a very difficult one. Lie detection, for example, is a very interesting application of MRI. And people are actually using MRIs now to detect lies for job applicants. You won't believe it. So if I am lying in my CV, is actually, some small helmet kind of a thing is put on my head when I'm giving an interview, and the guy can figure out, so 3 regions of my brain actually lights up like Diwali time Delhi to tell that, I'm not telling the truth. So there are a number of use cases where we look at it from the corporate's perspective, from the employee's perspective. Essentially, we have covered the customer's perspectives from our other clients as well, from our other friends as well. So it's infinite, but it's limited not by technology, but by our own understanding of how our own brains work.
I think all pretty interesting scenarios we sort of discussed, right? I was sort of even thinking how would I read my wife when I sort of go back late home, right? And like, what should I do? I mean, what kind of emotional intelligence I should apply, right, when I have to actually talk to her, right? And but again, that's on the fun side of the world, right? And
so Rajesh, why don't you share some of your experience from the professional world? I think we would like to hear that as well.
Yeah, so I sort of was, I mean, pretty interesting, right? I mean, so I actually lead the machine learning hub in India for IBM. And so as part of that, I mean, I sort of get to work with different customers in different domains across, right? I mean, right from retail, healthcare, finance, insurance, and all of those, right? And what has been interesting is when you talk about each of these, you're sort of dealing with a certain set of pattern, right? Because you have data which you can actually build a pattern on, and you can apply some kind of intelligence when you talk about machine learning in general, right? But when we talk about emotional artificial intelligence, right, it is so different, right, where you sort of need to now start to understand human emotions, and it's so different where humor, for example, right, and how somebody interprets humor, right, versus someone else interprets humor is so different. Or even how sarcasm people talk about, like when you're so sarcastic when you actually talk to somebody. Right, we were also talking about when we spoke to a firm which sort of deals with HR stuff, right, and they were saying they've been asked to come up with some kind of a scenario where they say when you're doing assessments for employees, right? Now what is actually going through the employee's mind? It's not just about reading what the employee is actually telling you, what is the body language telling you, and how do they sort of come up with different patterns, right, and then they can sort of apply those, right? And those are some of the key challenges which we have been seeing, especially when you talk about emotional AI, right? And while it is simple, when you talk about doing things with specific domains like banking and all, it's very straightforward, right? You know how much somebody is actually spending, right, and when they're actually spending, or is it beginning of the month they're actually spending so much of money and all that. So you can sort of derive patterns out of it, and then you can apply intelligence on it. But when it comes to humans, right, it's so different. So again, we're going back to some of the other questions which we sort of spoke about. So Ganesan, you coming back again to the healthcare side of the world, right? When you talk about scans, for example, right, and how do you interpret scans based on human emotions, right? Like for example, if somebody is really sad or somebody is really annoyed when they're actually going through a particular scan, so the results actually interpret things in a different way, right? Or like what kind of things you're actually taking care when you're building your solutions to deal with these kind of emotions, so that you sort of can make it more generic.
There are a couple of examples. For example, MR machines were they are big and noisy. Okay, I don't know if any of you have taken an MR exam or a CT exam. It's a very scary process, and you should not move at all. You should lie very quiet, and also you should even hold your breath when the MR exam is happening. Now, it's very easy for us adults to do that, but it's very difficult for children to do that. And also, some people with developmental disabilities, they will not be able to control, or if they have a motor neuron problem or something like that, then it becomes even more challenging. So I'm not sure whether it was Phillips or GE who did that first, but they had to make a special MR just for children. They had to redesign the entire MR room with putting Disney characters on the top, play some music and all that kind of stuff. So you need to understand how the user is going to perceive what exactly you are going to do. Whether it requires an automated system to understand your emotion is something, it depends on the situation. One of the other scarier things is that when you're in an operating table and you're anesthetized, there are situations when which you can feel pain while being operated, okay, and you cannot express it because you are sedated and your muscles are paralyzed, so you will not be able to make even a sound, but you will feel the complete pain of getting opened. Okay, so these are situations where in which it's better to have an automated system to understand your emotions, either through skin conductance or your skin temperature or your maybe eye expressions or something like that. Okay, so and there are efforts going on right now to understand what are the biological processes that happen when you perceive pain, and how would you automatically give an alert to the user saying that the anesthesia did not work, so please stop.
Okay, so Tapati, so assume you were given the task of designing emotional AI, I think, for one of your customers. What would be the key aspects you would actually look for, and in terms of designing a particular solution, right? So what are the key things you would start to look for, and how will you overcome some of those issues what you just mentioned earlier?
Yeah, so essentially when we process emotions, there are three main components of it, right? So the first thing, as we mentioned, is about sensing it from multiple types of signals, right? So getting data across multiple different channels and collating them and making sense of it. Basically, that's the second part. So capture, then process, and then respond. So that respond part is actually where the design comes through. I'll give you a simple example. All of us talk about AI as, Watson gave us that, actually it started off with Deep Blue, which beat Kasparov, right? So the question is whether Deep Blue was AI or EI, emotionally intelligent, right? So it's one thing to have a bot beat me up in the game kind of a thing, and it's a completely different thing to have a bot which has EQ enough to handle my moods, right, as a user. So, how did Kasparov really feel, beaten by Deep Blue? I am sure he didn't feel good about it, right? So if Deep Blue was actually emotionally intelligent, if Deep Blue had high EQ, not just high IQ, then probably what AlphaGo, for example, Google have done, DeepMind. So what these guys have done is, DeepMind first of all had beaten the Go champion, right? But when it has gone to the next level of EQ, that is the closest we have gone so far. Sorry, it's not IBM, it's Google. And it's not Wipro Homes either. And we are partners with both of them, actually. So there, in fact, we talk about the machine actually training the human champion to beat itself. That is the AlphaGo Plus, which has actually come up with some moves in the Go game which none of the human Go champions could figure out, and now the machine has discovered those moves and is training the champion back so that the champion, the human champion, can actually beat the machine in its own game. So that is real machine EQ. And that is the kind of thing we need to crack. And that is where, in fact, between the, us panelists, we are discussing things in our room, that the use cases that we are talking about probably are too post facto, and we should probably look at use cases where we speak to our children. And this is something, again, which, some of the MIT researchers have done. So they have actually initiated a project with Lego and Hasbro that actually talks about how you can make Lego playing more interesting by, first of all, making it broken into steps so that you can reward the children through the game. So when you think of a 3,000 pieces Lego, right? We have one at home. I have two girls, but they are all Lego fans, right? So we don't have stereotyping. So essentially, out of those 3,000 pieces, you can't expect a child of 9 years to sit through, and cover all those 3,000 pieces at one go. So what they have done is, it's a Ferrari car, essentially. So you first build the chassis, then you build the engine, then you build the gearbox, like that. There are parts and pieces of rewards. So that is how we will have to design the UX when we talk about an EQ-enabled bot, so to say. So when you think about the fashion designer or the suggester bot, or you talk about a chat bot that is going to be EQ-enabled, emotionally intelligent. So there, in fact, we have to give instant rewards to the person who is using it. So that has to become part of the UX design, and that is the only way we will actually make the users like those bots. Because there is something called mirror neurons in our heads. And mirror neurons actually make us like someone who is very much like us. That is how human liking happens. So essentially, until unless I see that bot rewarding me like my mom used to do, I won't like that bot ever, no matter how effective it is. So that is something we have to keep in our mind when we are designing UX for those kind of stuff, that we have to break it in terms of steps where we can reward them, and we have to make it behave like our favorite people would have behaved with us.
Sure, sounds good. So Atul, when we talk about Amazon, right, I think like we spoke about buying dresses for a particular thing, and especially I think when we talk about our Indian stuff, so we normally don't pay too much of attention to how much of rating is actually given, rather we go by the price factor, right, which is a common thing, right? And also, like for example, if I have friends, and especially when you're shopping for some particular dress, so does it sort of look for similarities and say like, look, these are your kind of close pals and they are sort of buying something like this, and it sort of plays on your emotions so that you sort of don't end up buying something similar, so that when you go for a party, you're not wearing the same kind of dress. So what kind of things are actually coming up with Amazon, right? So that these kind of scenarios can be handled.
Right. So the social angle is something that sort of has played out for some time with all companies, including Amazon. So even Flipkart tried out the social angle to some extent. Amazon tried it internally and didn't float it out primarily because we weren't seeing very great success rates with the social angle. But you're right. Overall, sort of there exists the emotional part of what your friends like, and essentially sort of as we look at the human population, we as machine learning scientists or as data scientists or whatever, so we can be classified as types, and we are probably sort of a conglomeration of all the friends that we have. So yes, so that part is very, very essential. Just that sort of we do not have a direct mechanism of incorporating that as a feedback into the recommendation system. Right now, it's mostly sort of it's about sort of taking your emotions in as an individual. So the other portion that comes out is from a customer experience side. Now that's one of the biggest things that has not been worked out. So I feel that in the future success of such an application of emotional AI is going to be both from the customer experience point of view, and also from the ability of a company like Amazon or other companies to come up with commercial hardware that is sort of that can be produced scalably and reliably. That enhances the customer experience, because what tends to happen with such applications is that in case the customer has a negative experience, the usage pattern of such applications dies down. And once the usage pattern dies down, as in machine learning is completely dependent upon data that you get back from the customer and the user. And if that was to happen, that would sort of lead to an immediate failure.
Sure, sounds good. So Sachin, your app, right? I think you said it sort of comes and gives you suggestions and all that stuff. So how does your app handle sarcasm? Like, I could be sarcastic and I can say something versus I'm sort of really looking for an answer, but because sometimes English is a very funny language, right? I think we tell something and people can interpret it in 10 different ways. And so how does your app actually handle those, especially because sarcasm is so emotional, right? And so how do you sort of handle those, or how did you take care of those when you're sort of designing your particular app?
Right. So as I said earlier, it's a little difficult for a machine today to understand sarcasm or anything that involves some level of ambiguity. So typically, what we do is we handle it with a built-in UX. What we do is we sort of throughout the conversation, in case if a user says something and it is not sort of in line with what the bot is expecting, so it just reiterates it and then tries to get a confirmation from the user. And the second time, if a bot asks a question, typically humans are curt enough to really give the right answer, and that's something that we've also seen that happens very frequently. In most of the cases, what we do is we give tips to the user in terms of how do they really, what kind of an answer is the bot is expecting, and that sort of remarkably improves the conversion rate. Because for us, more than understanding emotion, the conversion rate is one of the most important factor when we're looking at especially commerce per se. Users, we can keep the users engaged for as long as we want, but for us the core metric that we track off is what percentage of each session convert to an order. And irrespective of the mood of the user, we all know that if a user has come to Niki and they typically want to buy something, so the best approach would be to get him to buy that instead of continue to engage in a chit chat, which may be different. I completely sort of agree with that it may be different for different applications. For us, our core metric is sort of to take him to conversion, so not really to keep him engaged for a long time, but to take him to completion as fast as we can. For some applications, engagement is very important, where they do measure emotions. For example, it's a very important study, very famous as well. A couple of researchers actually studied patterns in users when they use Facebook, and what they did was they started. So in fact, Facebook's researchers were actually doing this. They started feeding certain categories of feeds of posts to different set of users, and they realized that it evoked the same kind of response that they wanted. So if they were consistently being fed with more more depressing news, they were more melancholic, and that was the kind of emotion that Facebook was able to generate. So, but it all depends on the context of the application as well. Not all applications require users to sort of understand emotion as well as such.